Very soon, NASA will be sending a new probe to Mars. It's called Mars Insight, and it's a lander that will teach us more about the history and evolution of Mars. After traveling over 300 million miles through space and reaching the Martian atmosphere, Insight will have only 6 minutes to slow down and land safely. It will be going 14,000 miles per hour and carrying more mass than the previous Phoenix lander. Insight is also scheduled to land at a higher elevation, known for severe dust storms. All these entry, descent, and landing challenges must first be worked out by the engineers and scientists back at the lab.
So my role on each of these projects is as a flight dynamics engineer. And so what we do is we build computer-based simulations of the vehicle and the environment that they're flying in. So we develop the trajectories, and we feed back information to the project about where the vehicle's going to land, how hot it's going to get, how many G's it's going to pull, all kinds of things you need to know to assess flight performance or how well a vehicle is doing or how well a vehicle landed. And those are all the information that we give back to the engineers, and they kind of use that to revise their designs. It's very exciting because every time we fly, we're learning more about the design, we're learning more about the system, and we get to incorporate new technology into the next iteration. After Insight, we'll launch Mars 2020, but with some improvements. We'll be flying terrain relative navigation, and that's the very first time we've ever actually come in for a landing, assessed the terrain, and picked a landing site based off of what we've seen instead of just pre-selecting a landing site. And so that's something that we hope will feed into future human missions, and even our Mars sample return, which will hopefully come after Mars 2020. It's a very cyclical process. We learn everything from the past that we can, and we apply all those things to the future projects and future missions.